On the night of 1st July 2002, Bershiken Airline, Tupolev Jet and DHL Boeing 757 have collided mid-air over Uberlingen in Germany. What is the cause of the accident and what type of system used by both aircraft? Let's take a look on this video.
In this particular incident involved two aircraft, which are Boeing 757 for DHL and Tupolev Tu-154M for the Russian airline. Both of these aircraft are using the same transponder, which is Tcas 2 Honeywell 2000 version 7. For this version, the components are the first one, CPU 67A Tcas processor, the second, MST67A mods transponder, the third one, GC362A graphic processor, fourth, dual L-band omnidirectional antenna, and the last one, ANT67A directional antenna.
Tcas involve communication between all aircraft. Nowadays, Tcas has been equipped into all aircraft for communication for one aircraft to another aircraft. The Tcas also provided transponder to enable and set up properly, which is one transponder releasing 1.03 GHz radio frequency, and all other aircraft reply to other interrogation by 1.9 GHz of radio frequency. This interrogation and response cycle may occur several times per second. Tcas also built a three-dimensional map system, which is conclude the range of the aircraft, the altitude, and also bearing of the aircraft. And Tcas variants are only able to interact with aircraft that have a correctly operating mode C or mode S transponder. Mode S transponder nowadays is used for modern aircraft. A unique 24-bit identifier is assigned to each aircraft that had mode S transponder. These avoidance maneuvers are communicated to the flight crew by a cockpit display and by synthesized voice interaction. Tcas also equipped aircraft for protected volume of airspace surrounds. For Tcas traffic display, they have 4 signs in the display of the aircraft. First, diamond shape. That means the other aircraft is non-threat traffic and the other aircraft is more far from our aircraft. The second one is circle sign, traffic advisory. This sign to command us that the other aircraft is in the same altitude with our aircraft. The third one is the fully square. This sign is show us for resolution advisory, and for this sign they show us that the other aircraft is near to our aircraft. And the last one is fully diamond for the non-threat traffic. For this sign, they show us that the other aircraft is very close proximity to our aircraft. The most advanced version of Tcas is called Tcas 2, used by airlines worldwide. This TA is provide 2 types of alerts. First is traffic advisory or TA that give flight crew a heads up that there is an aircraft nearby could potentially cause a problem. A TA is triggered when the intruder aircraft is about 20 to 48 seconds. The actual times vary, which aircraft speed, altitude, and maneuvering. A cockpit speaker also will give a sign for traffic, something like that. The second one is resolution advisory or RA. The second Tcas alert is Tcas will determine that the aircraft into the aircraft is about 15 to 35 seconds away. This altitude, direction, and also speed of both aircraft to calculate and issue a resolution. The pilot of the aircraft with Tcas will be advised to climb, descend, or maintain altitude. Example of the speaker will command to the pilot like climb, climb, and the second one descend, descend, or climb, crossing, climb.
Contributing factor 1, single man operation. On the night of the accident, there were two controllers on duty working. Only one controller worked at the given time, while the other controller is on break. An accepted and long-standing arrangement, the presence of only one controller working the radar screen represents one of the underlying causes of the accident, namely lack of supervision or assistance in safety critical situation. Contributing factor 2, downgraded radar. On the night, maintenance work was being done on the main radar system, which placed radar service in their fallback mode. As a result, separation minimum between aircraft will increase from 5 miles to 7 miles. The fallback radar mode also meant that the STCA was not available. Contributing factor 3, dual frequency responsibility. On the night of the accident, the controller was monitoring two radio frequencies. The first used by any aircraft and the second is used for the approach. Next, contributing factor, Tcas. Tcas is designed to provide not only traffic advisory but also solution to communication to avoid mid-air collision. And it was in fact this system that alerted the pilot of both aircraft to the landing complete a full 7 seconds before the controller, who was busy vectoring another aircraft in for landing using a separate radar screen. After the pilot were alerted to the collision, the Tcas instruct the DHL pilot to descend and the T154 pilot to climb. However, note that T154 had already been instructed by the controller to descend. This choice resulted that two technical issues be considered. Firstly, Tcas does not provide the controller with information regarding the solution advisory. The pilot only knows the advisory, therefore, the controller had no way of knowing that the system had instructed the T154 to climb, resulting on honest decision error on the part of the controller. Second and more importantly, Tcas does not account for situations where one of the aircraft doesn't follow its instruction. In the present case, T154 disobeyed its own Tcas instruction to climb and descend to SL350. This result in the Boeing 757 cockpit was an instruction to increase the rate of descent. Lastly, contributing factor is Tcas. Tcas is designed to provide not only traffic advisory but also resolution recommendations to avoid a mid-air collision. And it was, in fact, this system that alerted the pilot of both aircraft to the bonding conflict a full 7 seconds before the controller, who was busy factoring another aircraft in for landing using a separate radar screen. After the pilot were alerted to the collision, the Tcas instructed the DHL
DHL pilot to descend and the T154 pilot to climb. However, note that T154 had already been instructed by the controller to descend. This draws a set that two technical issues to be considered. Firstly, Tcas does not provide the controller with information regarding resolution advisory. The pilot only knows the advisory. Therefore, the controller had no way knowing that the system had instructed T154 to climb, resulting an honest decision error on the part of the controller. Second and more importantly, Tcas does not account for situations where one of the aircraft doesn't follow its instruction. In the present case, T154 is obeying its own Tcas instruction to climb and descend to FL350. The result in the Boeing 757 cockpit was an instruction to increase descent rate rather than remaining at level its original altitude of FL360. At this window, safe separation could have been maintained. There is a few suggestions that we make to avoid a mid-air collision. Based on previous accidents, when presented with complete information between ATC and Tcas, the pilot are advised to follow Tcas. The Russian pilots are trained to take both into account before delivering a decision. We suggest that this has to be standardized, so the pilot clients are required to obey and follow Tcas Resolution Advisory (RA), regardless of whether contrary ATC instruction is given prior to, during or after the RA. Unless the situation is too dangerous to comply, the pilot client should comply with the RA until Tcas indicates that the plane is clear to the cockpit. Second, the Federal Office for Civil Aviation should ensure that the aircraft control service provider issue and implement procedure to undertake maintenance work on the ATC system, stipulating operational effect and available redundancy. Third, in the event of an aircraft resolution advisory (RA) to alter the flight path, pilot shall respond immediately and maneuver as indicated, unless doing so will jeopardize the safety of the airplane. Never maneuver in the opposite sense to an RA, nor maintain a vertical route in the opposite sense to an RA. The Federal Office for Civil Aviation should ensure that the air traffic control units of the air traffic control service provider are equipped with effective short-term conflict alert system covering the following minimum demands: an appropriate indication of failure or unavailability of short-term conflict alert system at the aircraft air traffic controller workstation, an adjustment of volume that prevents the controller from missing on-call SCCA when activate the acoustical SCCA warning should sound permanently until acknowledgement at the affect workstation by the ATCO. Lastly, the FOCA should ensure that the air traffic control service provider equips air traffic control unit with telephone system with in case of a failure or shutdown of the main telephone system, review incoming